Okay. All right, stream is up. Let's do some PCB work. Let me start the recording for YouTube. Do I need to do that? I'm going to try and do the export again. I'm just going to try YouTube. If you're watching this on YouTube, I just tried to export it straight over from Twitch, not doing a separate recording. And so what we're going to do today, second recording today on Twitch, is let's do some PCB work. So I mentioned in the last video, we were testing the display. This guy's got wires all over it for all kinds of testing, but let's grab one of these. So the hardware came in and it's awesome, first of all. So this is what we've been working on. We finally got it back. I plugged it in and it did not program. And what happened was, for those that haven't been following, I made a stupid mistake. And so we're going to fix that mistake, and I'll talk about it here in just a second. And we're going to fix the header, which I mentioned in a previous video. The header that's across the top here, the footprint is flipped, and so we need to fix that. But a much bigger problem came up when we got the hardware back, so let's take a look at that. So let's open up our schematic, and let's take a look. Well, actually, let's come to our schematic. This is a huge mistake, and I am so embarrassed that I made it, but the board wouldn't program, and the reason it would not program, as it turns out, when I came back through and I started testing things and looking at it, is if we come into the FTDI chip, the FTDI is going to have a transmit and a receive. Transmit being going out, receive coming back in. And so it's going to take the USB data negative and data positive and turn it into just a transmit and receive. And so as you're sending data down the USB pipe, the FTDI chip's going to send that out over the transmit pin. And as the ESP32 sends data back, that's going to come into the receive pin and, again, go back out over USB. So it handles all of that conversion. Now, the problem that we ran into, and this is where labels can throw you off, and it's definitely the problem. The issue I had was that I labeled everything too well. And you'll see what I mean here in a second. So I labeled this the transmit pin and this the receive pin. You can see the transmit pin is an output. It's pointing this way. And the receive pin comes in. But if we come back up a level here, I labeled that TX and RX. And then I came right over here to the TX pin on the ESP32 and did TX, and the RX pin and did RX. You just connect the TXs and the TXs and the RXs and the RXs. The problem with that is the transmit pin coming out of the FTDI chip needs to be connected to the receive pin. You know, it's talking, so the ESP32 needs to be listening on that pin. And then the transmit pin on the ESP32 needs to connect to the receive pin on the FTDI chip. And so we just connected transmit to transmit and receive to receive, which gives you nothing. That means the USB can't talk to the ESP32 and the ESP32 can't talk to the computer over USB. And so all we need to do is switch those two pins, which is the dumbest mistake. And so really, we can just come right over here. I still like calling this TX and RX because that's what they are. I think right here is where we will switch them to fix this. And it's been a while since we've been in here. Label RX. We're going to make this TX. And we're going to come up here to this label, press E. We're going to select label TX, and we're going to change it to RX. And we're going to save that. And that is it. That is such a simple mistake that I made that I should never have made. That's such an easy thing that I could have caught. And now it's going to cost us a couple $100 because we're going to have to do another run to make sure we test all of this stuff. Now, if this were the only problem, I might not do another super small run. I might do just like a pilot run, maybe like 50 to 100 that we could actually sell. But in this case, there's a couple of other things with the footprint being wrong that we're going to do another small run of 5. So RX and TX, that is great. And now if we come back over to here, it should update. How do we... I'm not sure how to propagate that in KiCad. Like, we saved it here. We need to update the net list here. So let's see. Update PCB from schematic. So we're going to do that, and it's going to say, oh, we changed some values. That's right. We fixed that last time where we changed the part number. We changed the R20 value from 3 to 0.47. Yep, that's expected. And then here's our RX, TX, TX, RX change, which is great. So we'll do update PCB and close. And now I feel like we should get some... Oh, it just says, hey, you need to connect RX to TX. That's not exactly what we're looking to do. So what we're going to do is, how do we want to move this? TX and RX. Let's just completely... Whoa. No, let's just wipe out this to make sure that the net list draws correctly. And I can tell you right now, the grid feels weird. 10 mils. We don't need it to be 10 mils. Let's change it down to 5 mils. No, let's leave it on 10 mil. Grid 10 mil. It's nice to have it on that for drawing. So, okay, see, now it's got it right. It says, hey, your RX needs to come up to here and your TX needs to go down to there. And so I'm trying to think, we could just leave everything else in place. Yeah, let's do that. There's no reason to redraw the whole thing. So let's get rid of that. And let's get rid of the via right there. And then what we'll do is we'll just, I see it's been a couple weeks now. I can't remember the shortcut for the trace route tracks. We'll just carry this out a little bit more. Why does that look crooked? Does that feel crooked to you? No? Okay. We'll just take it out to here. Oh, it's fatter. That's why. Control Z. Come on. Control Z? No? We can't undo? Oh, we have to exit. That's what we got to do. Now we can Control Z. Yeah, we definitely don't want... No, our grid's fine. We want our track. Here we go. I think that's an 8 mil. Yeah, there we go. So we're going to drag this one a little bit further out like that. And then let's drop a via right here. That's too big. We need to change our vias. That's probably a 6.3. Nope, it's not. It's a... what size did I make that? That's not right. I should have had these all stored. No, come on. Let's get information about this via. This one is a 2311. Do I not have that in here? 2311, yeah, right there. What's going on? There we go. All right. And then we'll pop a via right there. And then what we can do is we can cross over our, you know what? I think I want to do this a little different. I think I'm going to delete that. I'm going to delete that. I'm going to delete that, and I'm going to delete that. What I'm going to do is so I've got to come over here with my, let's push this out just a little bit. I'm going to crisscross them right here. So let's grab that and let's come down a little further. This one's got to be like right there. I'm going to come a little further down. We'll do like that. And now this should pull us right into there. Cool. Okay, so that takes care of transmit. And now back over here, we can pop up. And then there we go. Just like that. Perfect. Just like that. That's what I'm trying to do. We'll just cross them down here. We probably could have, let's see where they run up here. TX, well, we had to run them down either way, so, okay. I'm gonna call that good. So we just cross them that way, and then they go right to where they're supposed to be. Great. Perform design rules, check. Oh, it's not that. I want to run the net. Load net list, no. Oh, I guess it was the design rule check. So I think we're good there. Well, let's go ahead and run it. Run DRC. Let's continue without refill. We'll refill those in a second. Unconnected items, we've got 71. That's because we have our fills out. So I guess we'll have to put our fills back in to make sure. But that should be good. And I deleted the fills so that we could see. I didn't delete the fills, sorry. I kept the ranges of the fills, but I unfilled them so that I could see all the traces and things. So now we are fixed. Our transmit and receive lines are fixed. So that's great. By the way, just while we're here, this JTAG thing seems to be working. I haven't fully tested JTAG debugging, but this connector seems to be working really well. So I'm pretty pleased with that. So, okay, so that was the big issue, was fixing the transmit and receive being switched. Now, okay, so another thing that came up was, oh, I don't know if you'll be able to see this. Now let me switch to the webcam only. All right, here is the case, and you can see right in here, there's this thing that runs down. It's got a space right there in the middle, and then it runs right here, and it runs right here. And that's a support. And if you look at the old hardware, this was not a problem, because if that will autofocus, it's not going to autofocus. Oh, there, well, kind of. There's nothing, it's perfectly in line with the standouts, and it comes down here, and then there's the cutout, and then it picks back up down here and goes all the way down to the bottom. On our board, however, and I don't need to show you on here, I can just show you here in KiCad, so let's switch back over. Right here off the center of the standoff, we've got these capacitors right here. We've got a capacitor right here. This would be where the cutout is, but it lands on these things. And so we don't have room for that. And so I could do a couple of things. We could move these to give this, basically what we would be doing is creating a keep out area right here for that support. However, I don't think that support is really truly necessary. And over here, it's even worse. It hits all of this stuff because the support comes right through here. And so over here, I don't really have. Up here, we could just move these capacitors and make it work. We could slide these all the way over. Down here, we got the whole power block that I'm not moving to make a keep out area for that. What we could do though is the standoffs on this also come off at like a 45-degree angle, like right here. And so we could move R3, which would be fairly helpful. Even just rotating it and putting it up would be fairly helpful. So you know what? Let's do that. Let's just grab, let's take this net, delete it, and grab this guy. We're gonna move him, and we're gonna rotate like this, and we're gonna stick it right up there. We're gonna just butt them right up to each other. And we'll give them a little bit of space. There we go. And we'll draw this back out like that. Oh, that didn't go right. Let's delete that guy. Oh, no. There we go. Okay. And back to route track. I don't like how that's, there we go. Perfect. Okay, so now that's connected, and that gives us a little bit more. So if we have a 45 support coming off here, we can connect it to that. So that looks good. Let's save that. Okay, so great. That is taken care of. So the next thing that we talked about in a previous video was this entire header is mirrored. And so what we really need to do is change the part. So this pad, we'll zoom in here, this SPI3 Mossy, I'm not sure how you pronounce it, should be up here. The MISO should be down here. This one should be up here, and along we go. And that is easy enough to fix in the schematic. Let's actually fix it over here in the schematic. Let's come out of here. Zoom this out. It's this header right here. Let's edit this guy. And all we need to do here is on the footprint, see how it's pin 1 left. I don't know how well you can see that, but we're going to change it. We need to be at pin 1 right. So this pin, you'll see it's going to move over to here. They're all going to mirror if you pay close attention. There we go. And that's what we want. We want the pin 1 right. And we'll hit OK. And we'll save that. And if we come back over to our schematic, and we update the PCB from schematic, you'll see that we changed J4 footprint from the pin 1 left to the pin 1 right. I'm going to update the PCB, close, and now everything is disconnected and off because the footprint's all moved. And so what we can do, I think, here is let's get rid of, well, let's just start deleting. Yeah, let's just clean up all these vias and these runs. Track via, get rid of all this random copper here. This one we could probably just take a little further, so I'm just going to need to delete the via. Same thing here. Yep. Okay. Just clean. Oh, nope. There we go. And just clean all this stuff up and get it connected to where it is. See, this one's like the via is like right on top of the footprint now. Nope. Okay. This one I'll probably leave all the way here for now. I might just bring the via a little bit further up. This one, track. And I don't think, oh, this one actually worked really nice. Leave that there. That one just goes straight up. This one will have to pop up. Yeah, so these aren't terrible. This should be pretty easy to fix. And ground. Oh, this one's going to be super easy to fix. Just pop right over. Okay. All right, we've got all that cleaned up. The footprint is now correct. Let's just go through one at a time and fix them. I believe they're all 8. So like, just go up to here, via, great. These ones are going to be the long ones. Yeah, we want to be on the bottom side though. Oh, auto track width. When starting on an existing track, use its width. Otherwise, use the current width setting. That's super nice. Is that like a turn on or? Yeah, that was turned off. No, we definitely want that on. That's cool. And yeah, I want to be on the bottom though. And we're going to come up here. This is all on the bottom, so we're good. Wait a minute. So these two things cross. Clock and MISO cross. Why don't we just switch those? Yeah. So they cross now because of how that works. So instead of this being here and this being closer. So let's just make those, let's just fix that. Let's just make MISO and clock pins swapped. Right here. And we'll just make this, because it doesn't really matter. It's just breaking out to our header, not heado. And we'll make this one clock. Yeah, okay, save. Come back over to here, update. We change those connections, update PCB, close, and now we're all set. Now we can just come straight up and do a via, like right there. And there we go. And the same thing for here. This is going to be on top again. Let's set it back down the bottom. Same thing, we can just come right up. Whoa, whoa, whoa. There we go. Via. And there we are. Okay, ground. Wait, IO22. Where are we getting IO22 from? Oh, right here. We went underneath. Okay. Let's no, that's not what I want to do. Well, I do want to do, yeah, there we go. Is that really what we want to do? That feels weird. Let's track, okay. And Okay, I'm coming up through here. Okay. So let's, again, we're on the bottom. Oh, I need to get back on here. I feel like, was it drawn like that? Yes, I want to come right through here, just like this. And I want to punch a via, like right by the pad, like that. Where'd that land? Great. Underneath the ground. Yeah, that's very similar to how it was before. Okay. That's great. Now, oh yeah, this one is a piece of cake. The slam dunk. Put a via right there. Come up into there. IO 26, perfect. Via. Okay. IO 30. Oh yeah, this is another super easy one. Great. Just punch a via right there. Cool. And this one will attach itself to ground. Oh, and this one is super easy. And there's that auto size. Great. Okay, I think that covers everything. We got that footprint. Okay, so let me look at my notes here. We had the RxTX, we fixed that. We had the, oh, that's not the right piece of paper. What else did we have? We had to fix the header. Okay, I think that's it. So the one other change that, oh, I'm not sure if I want to tackle with this is these cutouts right here were just a little bit too big. They could, and when I say a little bit too big, I mean a little bit too big. Maybe like 1/4 of a millimeter. And so I feel like, I feel like, let's see. I don't know how much that is. Let's just do a distance measure with, no, not dimension, yeah, calipers. Like this is 4.32 millimeters, and I feel like it could be, let's see, 4.06. That's about 1/4 of a millimeter smaller. I guess. Man, that worries me. Getting these. Yeah. 4.32. So we could make those a little bit smaller. I don't know. I don't know that I'll bore you with that. That's going to take some time. Like these drawing these things was like the hardest part of doing this. And if I remember correctly, how do we, I want to select, oh, what do we do? I think I zoomed in. Oh, there we go. Went way off somewhere. Okay. Yeah, so those are, you know, a length that we would need to also shorten a little bit. like ever so slightly. Let me grab one of these and put it in. I mean, we're talking so small, but it does wiggle just enough that, like, if you're plugging in a USB cable to this, like, it's got play. But it's really not a lot. Oh, okay. You know what? We got to do another run anyway. I'm going to commit all this stuff to the Git repo. In fact, let's do that. Let's grab our terminal. I'll show you that because that's, you know, something that we're doing here. Stat feeder hardware. Okay, so the fab main and main XML we're fine with. So let's just do git diff eda main dot schematic. So we changed that to pin 1 right, and we changed some labels, so that all looks exactly what we would expect. Oops, Q. And then let's look at the main cache lib. I don't know, I guess, yeah, I mean, I don't know, that's probably right. Main.kycad PCB. We made a bunch of changes here. I'm not going to go through all those. And let's look at the display.schematic. Oh, we changed the resistor on that. I bet you that's what it is. Oh, on the display, yeah, we changed that part number, and then we moved that, and then we should have also had that's the small cap. I guess we changed the value beforehand. Okay. Q. So let's add EDA display, EDA main cache lib, EDA main dot schematic, and EDA main dot kycat PCB. Okay, cool. And then we'll do git commit -m. What did we? So we fixed fix rx tx. Update display diode, and we fixed. What was the other thing that we fixed? Oh, fix header. Yeah, and let's make sure everything is saved before we do that. Saved here, saved there. Okay, cool. Great. Okay, so now now that we're in a good state, we have that fixed. Now we can mess around with the standoffs and change those to be however we like. I think I will try and just shrink them just ever so slightly. So I've got to pull them in just a little bit here and a little bit here, shorten up how deep this is, and then that will help me draw a completely new arc. And we'll see how that fits. Although, so part of this, let me talk through this a little bit. Part of what's going on here is I am using, where did I put it? Right here. I'm using this case design that we already have, and to avoid redoing the case design, I could always redo the case to fit this. Like, I could leave this how I have it and then redo the case to perfectly match it. So I'm not sure how much time I should spend making this perfectly fit this when I could just change this for the mold that we're going to do. I don't know. If I change it, I'll let you know. Right now, I don't want to think about it. So that's going to do it for the stream. This time we fixed all those things. Let's see. Here's my fix list. Fix header footprint, did that. Fix swap to TXRX, we did that, and fix standoff cutouts. So that's all we know of so far. Some of the things that we have coming up, we need to figure out if JTAG debugging works. So that's something that we can do a stream on, as well as I'm still working on the new display. You know about that. Yes. All right. That's up next. We're going to make sure that JTAG debugging, OpenOCD debugging in VS Code works for our platform. We'll hook it up. I've got all the hardware I think that I need for that, and we're going to see if we can set a breakpoint in our code and debug through it. So that's what we will do on the next stream. Thanks so much for joining. I really appreciate everybody that's following. I hope you're finding it useful. If you have any questions, feel free to reach out, and I can try and cover them in a future stream. Otherwise, until next time, have a great day.